Okay, so integration. We're going to be looking at the area under a curve today. Hit pause, copy the lesson objective down. Once you've done that, hit play. And we're going to talk about area under a curve. Okay, so integration. We can use integration to find the area under a curve. And we can use definite integration to find the area under a curve between two set points. So there's our curve, and we can find the area under a curve, A, by integrating. And what we're going to do is we're going to look at a bit of theory as to why this is the case, and then we're going to shift and move on to integrating between 2 points. So I thought we'd go over the theory of why this is the case in the first instance. So we say the area under this curve here, up to this point, is given by A. So let's write that down. Let A be equal to the area under the curve up to point X. Okay? Now, what I'm going to do is I'm going to extend that area slightly by extending X. So I'm going to extend X slightly. Now, when we did differentiation, if you remember, a small increase in X we called delta X. So I'm going to extend that by a small increase, delta X. So this point here is X plus delta X. Okay? And the increase in area we're going to call delta A. Right. So I can give you the values then for the coordinates here. Okay, that's going to be X. My curve is Y equals f of X. So my coordinates here are given by X and f of X. I'll just put brackets around those. Let me just change the color of my pen here. There we go. So those are my coordinates there. And my coordinates here are given by X plus delta X and f of X plus delta X. Okay, so those are my coordinates at that point there. Just change my pen back to red. Now, I can estimate the area of this strip here by approximating it to a rectangle. Okay, so if I approximate it to a rectangle there, I can find the area of under the curve between these 2 points. However, my area is an underestimate of what it actually is because I'm chopping it off here. So the area is given by f of X times delta X, area of a rectangle rather. So we can say that delta A is actually larger than that, so it's greater than or equal to f of X times delta X. So this is an underestimate. Tell you what, let me just write that in blue. Now I can also overestimate delta A by going up to the point here and drawing a rectangle. So that's going to be larger than my curve there. The area is going to be larger than at that point. So this is my overestimate. I'll just change back to red. So in reality, delta A is going to be less than or equal to the area of this rectangle, which is given by f of X plus delta X. That's the length, and the width is delta X. So that's going to be f of X plus delta X times delta X. I can combine these two statements together with delta A in the middle. Delta A is less than or equal to f of X plus delta X times delta X. At the same time, delta A is greater than or equal to f of X times delta X. Okay? So we know that the area of delta A is between these two rectangles. Now I want to simplify that. in the first instance, what I'm going to do is, I've got delta x there and delta x there, so I'm going to divide by delta x. That leaves me with, if I divide there, I've got f of x less than or equal to delta a divided by delta x, which is less than or equal to f of x plus delta x. Okay, so I've got my delta x there. I'm hoping that you guys remember your differentiation from first principles. Okay, and when you saw me write delta x, hopefully you were thinking, I wonder if he's going to use the limit. And I am. So in the limit, as delta x tends to 0, what we have then is f of x. It's going to be less than or equal to, and it's the differential now, we change to d. So the differential of a with respect to x is less than or equal to, and this goes to 0, delta x tends to 0. Let me just change pen to write that. So that leaves us with f of x. Which is an odd statement really, because we've got f of x is less than or equal to the differential of a with respect to x, which is less than or equal to f of x. So we've got f of x on both sides. The only thing that makes sense for this statement to work is where f of x is equal to the differential of a with respect to x, which is equal to f of x. So I don't need two f of x's, so I can say the differential dA over dx is equal to f of x. And if I want to find a, then I reverse my differentiation, or, as we call it now, integrate f of x with respect to x, and I now have the area under the curve. It's given by the integral of f of x with respect to x. So that's a bit of theory for you. You know, do you have to learn that? No. Will you be asked to produce that in the exam? No. But it is background. It does allow you, hopefully, to understand where this comes from. Okay. So what I suggest is hit pause, make some notes, sketch the curve. It helps your understanding. It's not something that I want you to think, right, I'm going to have to revise that that bit of the area under the curve, the proof. No. Okay, just a bit of background for you. Good, so hit pause, copy that down. Once you've done that, hit play, and we'll look at definite integration to find the area. Okay, and to finish off, we're going to find the area under the curve of this strip here between points A and B, and in order to do that, these are values of x. All you have to do is integrate f of x with respect to x from A to B, so your definite integral. And that's the object of our exercise today, the most important bit. That you need to know for your exam. Hit pause. I'd say sketch the graph and then copy that down. Once you've done that, hit play and we'll look at an example. Okay, so we're going to try out our shiny new formula. It's on this example here. Find the area of the finite region between the curve and the equation y equals 20 minus x squared and the x-axis. Right, so I've got to find the area under the curve, but I don't have any coordinates for where it hits the x-axis. How can I find that out? Well, as we always do, we equate y equals 0, because at the on the x-axis y is equal to 0. So we can say x-axis, at the x-axis y is equal to 0, So therefore 20 minus x squared is equal to 0, and I don't like having a negative, so I'm going to multiply the entire thing by minus 1, which will give me, change all the signs, that gives me x squared plus x minus 20 equals 0. It's the same thing as taking everything over to the right hand side. Okay, so now I'm going to factorize to get my coordinates. It's x squared, so it's going to be x times x is equal to 0. And I need the factors of minus 20 that are going to give me positive x. So that means I think 5 and 4 will work. To be positive, it's got to be a minus 4. So x minus 4, x plus 5, which implies then that either x is equal to 4 or x is equal to minus 5. Let's just box that off because it causes confusion. So x equals 4 or minus 5, we can sketch that curve then, like so. X is equal to 4 or minus 5. Now we want to find the area under the curve there. So we integrate 20 minus x squared with respect to x. That's squared, by the way. It's better. Put brackets around it. From minus 5 to 4. It's going to be equal to, when we integrate, square brackets because it's definite integral. That gives me 20x minus x squared over 2 minus x cubed over 3. From minus 5 to 4. Okay, so let's sub in the values. I'm just going to bring my equal sign over here. I know it's out of sync, but I'm just running out of room. Right, so that's going to be 20 times 4 minus 4 squared over 2 minus 4 cubed over 3 minus 20 times minus 5 minus 5 squared over 2 minus 5 cubed over 3. Okay, I know people reach for the calculator about now, and there's actually nothing wrong with that. Let's just see if we can simplify before we do that. So that's going to be 80 minus 16 over 2 minus 64 over 3 minus 100 minus 25 over 2, and so minus and minus, so plus 125 over 3. Simplifying, what have we got? 80 plus 100, 180, minus 16 over 2, plus 25 over 2, so that's going to be plus 9 over 2, and then you got minus 64 over 3, minus 125 over 3, so that's going to be minus 189 over 3, and I suppose this can go in the calculator then, and that will give us 243 over 2. Good. Hit pause. Copy that example down. Once you've done that, hit play, and I've got a couple of questions for you to attempt. Okay, so not many questions at all really. Just a 9, I think it is. Yep. Won't take you very long at all. So good luck.